I am Dr. Sahaya Sudherson, Associate Professor, Department of Mechanical Engineering, Rogani College of Engineering. Today, I am going to discuss about the design of gearbox, which comes under the subject Design of Transmission System, subject code ME8651. Before we deal inside the subject, we can see about the course outcome. After successful completion of the course, the student should be able to analyze the concept of design in the flexible drive elements like belt, chain, and rope drives. The student should be able to develop a method, various types of gears with parallel axis. The student should be able to develop a method of various types of gears with inclination with axis. The student should be able to explain the techniques used in industrial design, multi-speed gearbox application. The student should be able to categorize a suitable design for cam, clutches, and brakes for automotive application. Design of gearbox. Introduction and purpose. Provides speed and torque conversion because of the limitation of the internal combustion engines. Also facilitates change of direction of output shaft for reversing. Automatic gearboxes are used to reduce load on the engine by manipulating torque and speed. They have the option to select one of several different gear ratios. Once the engine has reached a number of revolutions per minute, it is advisable to increase the gear to reduce the engine RPM to reduce the wear on the engine, allow more control and greater speeds, better acceleration and better fuel economy. Most gearboxes are used to increase the torque, reduce the speed of the output shaft. This produces a mechanical advantage. Automatic gearbox also have the provision to do the opposite. They provide an increase in output shaft speed with the reduction of torque. Requirements of the speed gearboxes. It should provide the design series of spindle speeds. It should transmit the required amount of power to be spindle. It should provide smooth silent operation of the transmission. It should have simple construction. Mechanism of gear speed gear should be easily accessible to so that it is easier to carry out preventive maintenance. Advantage and disadvantage of gearbox. It is include compact size, high efficiency, low backlash, and high torque to weight ratio. Disadvantage. Gearbox are a complex and costly design. Speeds in machine tool gearbox are in geometric progression. The speed in gearbox can be arranged in arithmetic progression, geometric progression, harmonic progression, and logarithmic progression. However, when the speeds are arranged in geometric progression, it has to be following the advantage over the other progression. The speed loss is minimum, the number of gears to be employed is minimum. Geometric progression provides a more even range of spindle speed at each step. The layout of comparatively very compact productivity of the machining operation, surface area of the metal removing in unit time is constant. The whole speed range also increase. Geometric progression, machine tool spindle speed can be selected easily from preferred numbers because preferred numbers are in geometric progression. Methods for changing speed in gearbox. The two important methods widely used are sliding mesh gearbox and constant mesh gearbox. This figure shows first one is sliding mesh gearbox, second one is constant mesh gearbox. Preferred numbers. Preferred numbers are conventionally rounded off values derived from the geometric series. There are five basic series denoted by R5, R10, R20, R40, and R80 series. Each series has its own step ratios. I series factor. The series factor for various series are given below. Series S5, manipulating series factor 1.58, S10, S20, S40, series, and S10. The series of preferred number is obtained by multiplying the step ratio with the first number to get the second number. The third number is obtained multiplying the step ratio with the second number. Similarly, to produce the continued until the series completed. Step ratio or series ratio or progression ratio. When the spindle speeds are arranged in geometric progression, then the step ratio, the two adjacent speed is known as step ratio or progression ratio. It is denoted by Y. Structural diagram and speed diagram. The structural diagram is a kinematic layout that shows the arrangement of gearbox. The speed diagram, also known as ray diagram, it is a graphical representation of the structural formula. Preferred structural formulas where x1 equal to 1, x2 equal to 0.1, x3 equal to 0.1 into 0.2, x4 equal to 0.1 into 0.2 into 0.3. For example, 6-speed gearbox divided the given 6 speed by 2 into 3. Here 0.12, 0.23. Now x1 equal to 1, x2 equal to 0.1. Therefore, it automatically goes to 2. Then structural formula 2 into 1 into 3 into 2. A 6-speed gearbox may be separated by 3 into 2. Now P1 equal to 3, P2 equal to 2. Now x1 1, x2 P1, then structural formula 3 into 1, 2 into 3. 8-speed gearbox divided the given 8 speed by 2, we get 2 into 2 into 2 equal to 8. Here 0.12, 0.23, 2, 0.32, x1 x2 2, x3 2 into 2 equal to 4, where x1 equal to 1, x2 equal to p1, x3 equal to p1, p2. Now the structural formula 2 into 1 into 2 into 2 into 2 into 4. 12-speed gearbox. Divide the 12 speed by 2 into 3. Now we get 2 into 3 equal to 12. Again, divide the given 12 speed by 2 into 3. We get 3 into 2 into 2 equal to 12. Again, divide the given 12 speed by 2 into 3. We get 2 into 3 into 2 equal to 12 here. Now the structural formula 2 into 1 into 2 into 2 into 2 into 6. First type. Second type 3 into 1, 2 into 3 into 2 into 6. Second type 2 into 1, 3 into 2, 2 into 6. Third type. Kinematic layout or kinematic arrangement. The kinematic arrangement of multi-speed gearbox is shown in figure. Shaft 1, driving shaft, shaft 2, intermediate shaft 2, shaft 3, driven shaft. From the figure, it is clearly that the kinematic layout shows the arrangement of gears in the gearbox. The kinematic layout provides the following information required for gearbox design. The number of speeds available at the driven shaft, the number of stages used to achieve to record spindle speed, the number of simple gear trains required to obtain the required spindle speed and their arrangement, the overall working principle of the gearbox, the information required for structural formula and ray diagram. The power is transmitted from driving shaft to driven shaft through a intermediate shaft. It is conventional gearbox. Speed changing is obtained using a sliding gear mechanism. It can be seen that the number of speeds from driving shaft to intermediate shaft 3 and that from intermediate shaft is 3, then the number of spindle speed is equal to 3 into 3, now 9. The structural formula for the kinematic arrangement of gearbox shown in figure is given by n equal to p1 into x1, p2 into x1, where p1 3, I stage 1 there are 3 speeds are available, p2 3, I in stage 2 there are 3 speeds available. Now x1 1 and x2 equal to p1 equal to 3. Structural formula z equal to 3 into 1 into 3 into 3, where n number of speeds available in the driven shaft equal to 9. P1, P2 equal to 3 into 3. Calculation of number of shaft to draw kinematic arrangement. Number of shaft equal to number of stage plus 1. If 3 stages are there in the gearbox design, then number of shaft will be 3 plus 1 shaft. Calculation of number of gears to draw kinematic arrangement. Shaft 1, P1 gears, shaft 2, P1 and P2 gears, shaft 3, P2 and P3 gears, shaft n up to Pn plus 1 gears. References. The data source referred by from the books Machine Design by Volume 2, Design of Transmission System by S.M. Jalaluddin, Machine Design by R.S. Kurmi and R.S. Gupta, Design of Transmission System by D.J. Prabhu, Design of Transmission System by V. Jayakumar. Thank you.